All right, let's get into it. In the world of software, if you're a developer, or even if you're just curious about how all this tech stuff actually works, there's this one fundamental choice you have to make over and over again. How do you organize your data? Now, it might sound kind of boring, but I promise you, this one decision can make an app feel magically fast or painfully slow. So today, we're putting two heavyweights in the ring: arrays and linked lists.
Seriously, just stop and think about that for a second. It's a weird question, I know, but the answer gets right to the heart of what we're talking about. The problems we solve in code have these real-world parallels, and understanding the difference between that playlist and that packed street is the key to building software that doesn't just work, but works beautifully.
Look, in software, it's all about data. Everything you see, everything you click, it's all just data. But just storing it isn't enough. How you organize it, well, that's everything. This stuff directly affects performance, how fast your apps feel, and yeah, even how much money big companies spend. Tech giants obsess over this because every tiny fraction of a second a computer has to spend searching for data costs them real money. So efficient storage means a faster experience for you and lower costs for them. It's a huge deal. Okay, so let's meet our first contender, the array. I like to call it the digital bookshelf. Imagine you have a whole bunch of stuff you need to store. What's the most intuitive way to do it? You just line them all up in a row, right? Side by side, nice and neat. That's an array for you. Now, let's get just a little technical. The one word you absolutely have to remember for arrays is contiguous. All it means is that every single item in the array is stored right next to each other in the computer's memory. They're literally neighbors with no gaps in between. And each spot on this digital shelf gets a number, which we call an index. So you have item 0, item 1, item 2, and so on.
And because of that contiguous layout, arrays have a superpower: instant access. It's amazing. If you want to get the item at index number 3 or index 500, the computer doesn't have to search for it. It knows exactly where the list begins, does a tiny bit of super fast math, and bam, it jumps directly to the right spot. It doesn't matter if the array has 10 items or 10 million, it takes the same tiny amount of time.
But you knew there was a but coming, didn't you? Every hero has a weakness. And the array's greatest strength, that rigid, perfectly ordered structure, is also its biggest flaw. So what happens when that bookshelf is packed and you decide you want to slide a brand new book right in the middle?
This is where things get really, really ugly. You can't just magically create empty space on that shelf. The computer has to find a whole new, bigger spot in its memory. And then, this is the killer part, it has to painstakingly pick up every single book that comes after your new spot and move them, one by one, over to the new shelf just to make room. Imagine doing that with 1 million items. This shifting is a performance nightmare.
So if the rigid bookshelf is a problem, what's the alternative? Well, let's bring in our second contender, the linked list. And for this, I want you to stop thinking about a bookshelf and start picturing a train of shopping carts, where each one is simply chained to the next.
This is the big, clever idea behind the linked list. What if we just threw out that whole everything must be side by side rule? What if we could just scatter our data all over the computer's memory, wherever there's space, and just leave a little clue in each piece telling us where to find the next one?
Well, that's exactly what a linked list does. Each one of those shopping carts is called a node. And a node is brilliantly simple. It holds just two things. First, your actual data, the number, the text, whatever. And second, it holds a pointer. You can think of a pointer as just an address or an arrow that points you to the exact location of the next node in the chain. It's the link that holds the whole train together.
And here is the magic trick. Remember that nightmare of shifting 1 million books? With a linked list, you can forget all about it. If you want to add a new cart right in the middle of the train, it is so easy. You don't move any of the other carts, you just unhook one link and change 2 pointers. You tell the cart before, hey, now you point to this new one. And you tell the new cart, okay, you point to the one that used to be next. That's it. A quick surgical operation that's incredibly fast.
But, as always in engineering, there's no such thing as a free lunch. There is always a trade-off. All that amazing flexibility comes at a price. Because all your nodes are scattered randomly in memory, there's no direct path to get to any of them. You have no choice but to follow the chain from the beginning.
And here it is, the big trade-off laid bare. With our array bookshelf, you want book number 50, you go straight to slot number 50. Instant. With our linked list train, you want to find the 50th cart? Well, you have to start at the very first one, follow its pointer to the second one, then the third, and so on, 49 times until you finally arrive at the 50th. This can be much, much slower. Okay, so time for the showdown. We have the rigid but fast-to-read array versus the flexible but slow-to-search linked list. So which one wins? Which one is better? And the real engineering answer is, it depends. It's not about what's best, it's about choosing the right tool for the specific job you need to do.
This chart really lays it all out. Let's just walk through it. Reading an item by its position, its index. Array wins, hands down, it's fast. Linked list is slow. Searching for a specific value, well, they're both kind of slow because you have to check each item one by one. Adding or deleting at the very end, both are pretty fast. But here it is, the main event, inserting or deleting something from the middle. The array is painfully, horribly slow. The linked list, that's its moment of glory. It's incredibly fast.
So what's the key takeaway here? It's pretty simple. If your program is mostly going to be reading data by its position, like get me the 5th item, get me the 100th item, an array is almost always your best bet. But if your program is going to be constantly changing, adding things, removing things, especially from the middle of the collection, a linked list will save you a world of pain. Understanding this is what separates a good programmer from a great one. So, I'll leave you with this final thought to chew on. The next time you're scrolling through your social media feed, where new posts are constantly being added and things are always changing, ask yourself, is the data behind this feed structured more like our rigid bookshelf or our flexible chain of carts? The answer might surprise you. Think about it. Thanks for joining me.